Time has come to introduce our guest for tonight. Welcome to today's episode. The Feminine Genius meets the Tiger MD with the theme, How Lucrative is the Semiconductor Industry Job? This is Late Night with Dr. Ria Liza, featuring Up Close and Personal with Engineer Leovic Tabalba Capili. Leo is a mechanical engineer from my university, my alma mater, Mapua Institute of Technology, now known as Mapua University, a board top-notcher, eighth placer. He has been connected with multinational semiconductor companies, and his stints, to name a few, include plant director of Schneider Electric, managing and business partner of actually I don't know how to pronounce, but it's Ino Manufacturing or Ino FMFG. Tanong natin sa kanya mamaya. MFG Philippines Incorporated, and Managing Director and General Manager of Cypress Manufacturing Limited. Medyo malapit sa akin itong mga semiconductor because way back when I was very young engineer, I had two projects in Gateway. It's where this Cypress is located, no? And also may mga naging guest tayo, yung mga angels who were apparently boss pala nila ang ating guest before, no? Marami tayong mga ECE students, no, na nagtrabaho sa semicon company. His journey was very meaty, and his contribution in the semiconductor industry are incredible, and we will hear from him later the story behind this contribution. Let us learn from the semiconductor industry's Tiger Managing Director, who is an organization leadership coach, a manufacturing and operations authority, a factory organizational turnaround expert, and technology and development startup guru. Let us give our virtual applause to Engineer Leo V. Hello, Leo. I'll just lalagay lang kita sa gitna.
Hello, good
Good
evening,
evening.
Ria, Anne, and Ella.
Good evening
Yes,
po, Sir Leo.
Good evening po.
yes, oo. Siyempre, actually, Leo, madami na tayo mga naging guest dito na
It's
mga taga
Leovic.
Mapua, no? Leo Vic, oo. Marami na tayo naging guest dito na mga ka-schoolmate natin, and I am so proud, no, to have known you. You are such an inspiration. We will give you the floor, Leo Vic. Iwan ka muna namin dyan to tell your stories. Uh, the floor is yours for your discussion.
Okay, you can hear me, right? Hello?
Hear you very clear.
Hello.
We
Yes
can
po,
hear you.
sir.
Okay, clear. Okay, thank you. I'm Leovic. My background is I'm a BS Mechanical Engineering graduate of Mapua Institute of Technology, batch 91. I'm happily with three sons. Firstly, my first son is already a graduate of Mapua as well. It's BS Multimedia Arts, and then he enrolled again for BS Animation LaSalle. My second son, Manila, and my third son is still studying BS Marketing. And my wife is also a graduate of the Mapua Institute of Technology as an ECE, batch 1990. She's one year older than me. I started my career in as a designer in the Ichi Seiko, which I was sent to Japan for training. I was there to train as one of the two Filipinos, and the rest are Japanese at the moment. And I was trained for 6 months to design mold and tool. And then after I finished my training in Japan, I came back to the Philippines and practiced what I learned in Japan and spent at least 2 years as a direct designer of mold and tool design for semiconductor industry. Mainly, I have some customers also in local Philippines, and most of them are in the US and Southeast Asia. And that time, my challenges I attained that time was I was away from my family for quite a while, 6 months. Before I left the Philippines, I took already the board exam for the Mechanical Engineering Board exam, October 1991. And then I passed the board uh, as one of the board top-notchers, number 8 to be specific. And I was not in the Philippines then, so I didn't take oath in Japan. So I just told my family that once I got back to the Philippines, I will have a good celebration with them and start another course in my life. Okay, and then after spent 2 years in as a designer in Daiichi Seiko, I was contacted and asked by Amcor Technology Philippines to join them as a preventive maintenance engineer. That was back then, 1994. I was a very young engineer that time, only about 22, 23 years old. And I learned the ropes of being a line engineer, as a mechanical engineer. It's ironic because I'm a mechanical engineer going into an ECA-dominated field with semiconductor. But I have to learn the ropes from the bottom going up. And I started to to align all the maintenance system in the first factory in Sucat, Parañaque. And after spending 3 years as a preventive maintenance engineer, I was asked to start up. That's the turning point in my career in semi. Start up a factory in Laguna, where I have handpicked by my boss then Ray Melia and Ron Pasqua to establish maintenance system in the factory. So in 1996, we built the plant 3 of Amport Technology ground up in Laguna Technopark, uh, where I have to qualify the building. Just imagine from qualifying the building to getting the equipments in, certifying the equipments, and run for production. I have those experiences hands on. And then once the plant was established, I was asked uh, to lead the maintenance team for the Super BJs. It's an advanced technology at that time, 1990s. Ball bead arrays in semiconductor. Uh, Super BJs, which application is supercomputers and military stuff, and plastic VGA, which is application for and it's a very good return to my career because I've learned a lot from from starting up a factory, qualifying a factory, equipment qualification, hiring people, and then run for production. Then after that, there was a continuous flow of technology at that time, and my boss asked me to develop both equipment and process for the third generation BJs we called chip array BGA. The chip array BGA is quite difficult at that time because you have to transfer the technology from the US, understanding a single panel type of BGA, and moving that single panel to a multiple panel to make it available for volume production. And that time there was no equipment then to accommodate the type of products for semiconductor. So what I did, I lead a group of technical people, 3 engineers and at least 7 technicians at that time to develop our own type of equipment. We fit up what we have at that time. Fit up the BJ, SBJ stuff into this particular high-end technology at that time, and make our own design for the tools and features of that particular new product for the semiconductor. And what happens there is that after we designed the fit up and tool ups, we commence with identifying the right vendors to help us uh, uh, improve and innovate what we have at the moment. So we talk about that particular aspect in the semiconductor industry while having no equipment at all. The cost is still young at that time, and then we come up with this 6 to 8 months of R&D with the equipment suppliers to fit up that particular development. So I have 2 difficulties in that time because at that time we had to adapt what's given to us by the US, but it's not what they call this. It's not a viable material at that time because you have to import materials, and then that particular material they gave to us was quite a high price. And in the semiconductor industry, you have to cut costs and make sure that the cost of manufacturing is low, so the profit would stay at 30 to 35% at that time. So what we did